Hello everyone, my name is Huwa Jia Sheng from Group 17, which is Data Miner Inferno. Today we would like to talk about our probability and statistical data analysis topic, which is breakfast cereal nutritional study. Now I will start with the introduction. In today's health-conscious world, understanding the nutritional value of breakfast cereals is vital for making informed dietary choices. Therefore, our study aims to analyze a dataset of 77 breakfast cereals sourced from the 1993 Statistical Graphics Exposition to uncover patterns and insights into their nutritional content. By investigating the dataset, we seek to answer questions such as: can one consume a cereal high in fiber without excessive calories? Are there correlations between different nutritional variables? And can we identify cereals that are nutritionally superior or inferior? Therefore, the dataset provides comprehensive nutritional information, including calories, proteins, fat, sodium, fiber, carbohydrates, sugars, and other variables. These metrics are crucial for evaluating healthiness of different cereals and understanding their potential impact on daily dietary requirements. The analysis involves various statistical tests, including hypothesis testing, correlation analysis, and regression analysis to uncover relationships and trends within the data. Our interest in this study stems from the growing concern about healthy eating habits and the role of breakfast cereals in daily nutrition. With increasing awareness of the importance of a balanced diet, this analysis will provide valuable insights for consumers looking to make healthier choices. We expect to find significant correlations between certain nutritional elements and uncover which cereals stand out as the healthiest options based on the provided data. Now I would like to talk about the data set and starting with the description of data. For the data, the population is all available breakfast cereals around the world, and samples is the 77 breakfast cereals included in the dataset. And as for the data description, we use different variables for each one. At first is the variable name, which represents the cereal name, MFR representing the manufacturer of cereal, in which A represents American home brew product, G represents General Mills, K represents Kellogg, N represents Nabisco, P represents Post, Q represents Quaker Oats, and R represents Ralston Purina. Following up is the variable type, which represents the type of cereals to be served, which is cold, and H is hot. There are also variables calories and protein, which is the amount of calories per serving or proteins in grams per serving. Following up by fat, which is fat in grams per serving, and sodium, which is the amount of sodium in milligrams per serving. Following up, we continue with the variable fiber, which is the dietary fiber in grams per serving, carbo, which is the complex carbohydrates in grams per serving, sugars, which is the sugars in grams per serving, potassium, which is potassium in milligrams per serving, vitamins, which is the vitamins and minerals, shelf, which is the placing of the cereal, weight, which is the weight of one serving in ounces, cups, which is the cups per serving, and rating, which is the rating of the cereal. Following up is the statistical test analysis, in which we selected variables, objectives, test analysis, and expected outcomes. At first, we selected calories and rating for the hypothesis test, which is a two-sample t-test, to determine if there is a significant difference in ratings based on the calorie content. The expected outcome is that the t-test will compare the mean ratings of cereals with high and low calorie content. A significant p-value, which is less than 0.05, will indicate a significant difference in ratings based on the calorie content. Following up is protein and fat, which we use correlation tests to determine if there is a correlation between protein content and fat content. The correlation coefficient will help us to measure the strength and direction of the relationship between protein and fat content. A weak positive correlation is expected. Then we use a regression test for the variables of fiber and sugar to determine the relationship between fiber content and sugar content. The expected outcome for this test is that the regression analysis will help us to understand how changes in fiber content are associated with changes in sugar content. A negative relationship is expected between fiber and sugar content. Lastly, we chose the variables shelf and rating to determine if there is a significant difference in ratings based on the shelf placement. We use the ANOVA test. The ANOVA test, which is the analysis of variance test, will be used to compare mean ratings of cereal placed on different shelves. A significant p-value which is less than 0.05 will indicate a significant difference in ratings based on the shelf placement. Next, we will follow up by data analysis, starting off with two sample hypothesis tests. In this analysis, we will use variables of calories and rating, where we will test the mean rating of cereals with high calorie content is different from mean rating of cereals with low calorie content. At the 95% confidence level, assuming unequal variances, from the data, frequency, mean, and standard deviations are calculated. The sample size of cereals with high calorie content is 18. Mean is 33.52 and standard deviation is 7.74. As for cereals with low calorie content, the sample size is 59. The mean is 45.46 and standard deviation is 14.39. We'll start the test by the statement of H0, which is mu1 equal to mu2, and H1, which is mu1 not equal to mu2, where mu1 equals to the mean rating of cereals with high calorie content and mu2 equals to mean rating of cereals with low calorie content. Given the 95% confidence level, alpha equals 0.05, test statistics can be calculated by using the formula T0 equals to x1 minus x2 minus 0 divided by square root of s1 squared divided by n1 plus s2 squared divided by n2, in which s1 is the sample mean of the first sample, x2 equals to sample mean of the second sample, s1 squared equals to sample variance of the first sample, s2 squared equals to sample variance of the second sample, n1 equals to sample size of the first sample, and n2 equals to the sample size of the second sample. Through the calculation, we find that T0 equals to negative 4.5641. The degree of freedom is then calculated by using the formula V equals to S1 squared over N1 plus S2 squared over N2 squared divided by S1 squared over N1 squared divided by N1 minus 1 plus S2 squared divided by N2 squared divided by N2 minus 1. With the formula above, we found that the degree of freedom V equals to 54.0907, which can be rounded off to 54. Therefore, using alpha equals to 0.05, we reject H0 if T0 is less than negative T0.02554 or T0 is greater than T0.02554. Therefore, the critical of T0.02554 equals to negative 1.96 and T0.02554 is equal to 1.96. Now, next is the conclusion. Since T0 equals to negative 4.5641, which is less than T0.02554, which is negative 1.96, the null hypothesis is rejected. Hence, there is sufficient evidence showing that the mean rating of cereals with high calorie content is different from the mean rating of cereals with low calorie content at 95% confidence level.
Okay, today I'm going to talk about the correlation test. In this analysis, we will use variables protein and fat, where we will test the strength and direction of the linear relationship between protein content and fat content. The correlation coefficient R is calculated, which ranges from negative 1 to 1. X, as you can see here, the legend is X equals to protein content, Y equals to fat content, and N is the number of observations, 77. As you can see here, as we are using a Pearson product, we made a table here, a simplified table of x plus y, x to the power of 2 and y to the power of 2. As you can see here, and then we showed the sum. So for the hypothesis statement, the H0 statement is that there is a correlation between the protein content and fat content, while the alternative statement is that there is no correlation between the protein content and fat content. Then we find the correlation coefficient of sample using Pearson product formula, as you can see here. Using this formula, we will get 0. R equals 0.2084. Then, with a 95% confidence level, we have an alpha of 0.05. To find the test statistics that can be calculated using this formula, using this, we will get T equals 1.846 with a degree of freedom of 75. Then we find the T critical value of the alpha, 0.05. And from that, we can see that the calculated T, 1.846, is less than 2, is less than the critical value. And as you can see here, we have the scatter plot of protein versus fat and the Chi graph. Since 1.846 is smaller than 2, the T statistic does not exceed the critical value. We do not reject the null hypothesis that there is no correlation between protein content and fat content.
Assalamu alaikum. I'm Anamul Hassan Rifat. I'll be explaining the regression analysis to determine the relationship between fiber and sugar content in cereals. So for this step 1, we start by calculating the means. Here 2.152 for fiber and 6.922 for the sugar content. These are the average values in our dataset. Then we move to the next step to calculate the deviation. We find the deviation from the mean for each value, helping us see how each value differs from the average. For the third step, to find the covariance and the variance using this formula, which shows how fiber and sugar vary together, and the variance of fiber, which shows again how fiber values spread around their mean. Step 4, which is regression coefficient. The slope here, the slope beta 1, is the covariance divided the variance of fiber, indicating the change in sugar content for each unit change in fiber. And the intercept beta 0 is the expected sugar content when the fiber is 0. Then we move to step 5 to find the RSS using this formula. Here we can see our results are for the intercept beta 0 is 7.489 and the slope is negative 0.263. So here we can see the negative slope suggests a slight decrease in sugar with more fiber, but this relationship is actually not significantly important. So in summary, we can say while there is a minor inverse relationship between fiber and sugar, it's not strong enough to significant.
Okay, for the conclusion, through this project, we analyzed a dataset of 77 breakfast cereals, performing various statistical steps to understand the relationship between different nutritional variables and identify which cereals are superior or inferior. So the dataset included comprehensive nutritional information such as calories, protein, fat, sodium, fiber, carbohydrates, sugars, and other variables. And through hypothesis testing, correlation, regression analysis, and ANOVA test, we examined the interplay between these nutritional metrics. Each test provided a unique perspective on the dataset, allowing us to draw meaningful conclusions about the nutritional profiles. Our first analysis is two-sample hypothesis test, which is comparing the ratings of cereals with high and low calorie content. The results indicated a significant difference in ratings, suggesting that calorie content influences consumer preferences. Next is the correlation test between protein and fat content, which revealed a weak positive correlation, indicating that cereals with higher protein content tend to have slightly higher fat content. Even though the correlation was not strong, it provided insight into the nutritional composition of cereals. Then the regression analysis between fiber and sugar content showed a minor inverse relationship, suggesting that higher fiber cereals tend to have lower sugar content. Finally, the ANOVA test examined the relationship between shelf placement and cereal ratings. The results demonstrated a significant difference in ratings based on shelf placement, indicating that cereals placed on different shelves receive different levels of consumer preference. This finding underscores the impact of product placement in retail environments on consumer choices. Overall, this study provided valuable insights into the nutritional content of breakfast cereals and highlighted the importance of various nutritional factors in shaping consumer preferences. Through these analyses, we gained a deeper understanding of the nutritional landscape of breakfast cereals, which can guide customers in making healthier dietary choices.